Good morning student. Today's experiment is salt analysis. Salt analysis can be done in 3 steps. First step, preliminary test. Second step, detection of acid radical. Third step, detection of basic radical. Finally, we have to write the report or result. So, preliminary test contains state, color and solubility. Let us check state and color and solubility. This is our salt. State is crystalline. Color is white. Let us check solubility. See here. I am taking a pinch of salt. Adding water. The salt is soluble in water. The salt is, see here, the salt is soluble in water. So, original solution is salt plus water. Next step is detection of acid radical. First, I will check the presence of first group acid radical. I take a salt or dilute HCl. Salt plus dilute HCl. See here, salt plus dilute HCl. No effervescence, no brisk effervescence. So, first group acid radical is absent. Now, we have to check for second group acid radical. Detection of second group acid radical. I am taking a salt in a dry test tube. I am adding concentrated sulfuric acid. See here, salt in a dry test tube. I am adding concentrated sulfuric acid to this. See here, what happens? You are getting a colorless vapors. See here, I am getting a colorless vapors. This colorless vapors becomes dense white when a glass rod dipped in NH4OH is held on the mouth of the test tube. See now how you are getting. See here, the colorless vapors becomes dense white when a glass rod dipped in NH4OH is held on the mouth of the test tube. It indicates that second group acid radical present, that is chloride. Second group acid radical present and that is chloride. So now I will do confirmative test for chloride ion. See here, for confirmative test I take salt solution. So this is salt solution. I will take a salt solution. For this salt solution, I am adding silver nitrate. Salt solution plus, this is salt solution. I am adding silver nitrate. See here, I am getting a curdy white precipitate. Salt solution plus silver nitrate solution, I am getting a curdy white precipitate. For this curdy white precipitate, I am adding excess of NH4OH. See here, the precipitate will completely dissolve. See here, the precipitate is completely dissolved. See here, I am getting a clear solution. This confirms the presence of Cl- ion radical. Now, we are going to detection of basic radical. Detection of zero group basic radical. For zero group basic radical, I take a salt. For zero group basic radical, I take a salt plus dilute NaOH. Salt plus dilute NaOH. Salt plus dilute NaOH. See here, I am smelling the gas. No pungent smell. No pungent smell of ammonia gas is observed. So, zero group basic radical is absent. Now, I move to detection of first group basic radical. For first group basic radical, I take salt solution. For this salt solution, I am adding original solution plus dilute HCl. See here, original solution plus dilute HCl, no precipitate. First group basic radical absent. Next, I move to second group basic radical. For second group basic radical, I am taking original solution, dilute HCl. For this I am adding H2S. am adding H2S. No precipitate. Second group basic radical absent. Then I move to deltas. See here, for third group basic radical, I take original solution. For this original solution, I am adding solid NH4Cl. Original solution plus solid NH4Cl. Then for this I am adding excess of NH4OH. See here, original solution solid NH4Cl and adding NH4OH solution excess. No precipitate. Third group basic radical absent. Then I move to detection of fourth group basic radical. For fourth group basic radical, already I take original solution. I am adding solid NH4Cl, then NH4OH excess. So for this, I am adding H2S. I am adding H2S. If I am adding H2S, see here, I am not getting any precipitate. No precipitate. See here, there is no precipitate. So fourth group basic radical absent. Then I move to detection of fifth group basic radical. I am taking original solution. See it? For fifth group basic radical, I am taking original solution. For this original solution, I am adding solid NH4Cl. Then for this I am adding NH4OH excess. Then for this I am adding ammonium carbonate. NH4 twice CO3. See here. So I take original solution solid NH4Cl, NH4OH excess and add ammonium carbonate. See, observe here. I am getting a white precipitate. The formation of white precipitate indicates that fifth group basic radical present. It may be barium, strontium or calcium. Let us first check for presence of barium. Now I am going to conduct test for barium. So fifth group basic radical present, barium present. So I am checking for the presence of barium. So for this I take original solution. See here. I take original solution. See. I take solution. For this original solution, see, for this original solution, I am adding potassium chromate. For this original solution, I am adding potassium chromate. See here, I am getting yellow precipitate. Formation of yellow precipitate indicates the presence of barium. So, the given salt contains basic radical barium. Now, I will do confirmative test for barium ion, BaCl2 plus ion, that is flame test. Now, I will conduct flame test. Flame test is the confirmative test for BaCl2 plus ion. I am doing flame test. Confirmative test for BaCl2 plus ion. Make a paste of the salt with concentrated HCl. Make the paste of the salt with concentrated HCl and ignite the paste using Bunsen burner. Here I am ignite this paste by using Bunsen burner. So I am getting an apple green. I am getting apple green flame indicates the presence of barium. See here. See. Apple green. You are getting apple flame indicates the presence of apple green flame indicates the presence of barium ion. So the given salt is barium chloride. Acid radical is Cl minus ion and basic radical is Ba2 plus ion. The given salt is barium chloride.